Okay, thank you everybody for rejoining our next Tech Talk by Koby Taswell on the importance of maintaining integrity in our bibliographic citation reference data formats.
All right, so hello everyone. I'm Koby, and I'll be talking about consistent bibliographic data formats with a project that we've been working on called the BabbleNewt Project. So obviously, as we've heard today and in past years of Guardian Workshop, citation use is absolutely a must, and proper citation is crucial. But storing that relevant citation data, so that's the title, that's the author names, where it was published, when it was published, etc. When you start to gather a catalog of hundreds, if not thousands, of records, becomes challenging. So we create tools for storage and management of that data. And there's lots of tools out there, from open source, freely accessible, to commercial, to those created for libraries, etc. Now, managing this data isn't just important for actually citing your sources in a paper. It can also be used for citation analysis, to calculate any number of metrics. A common one that folks are very concerned about in the world of academia would be impact of a paper, how often your paper is cited or how many citations a paper has garnered. But perhaps more importantly, for maintaining integrity in science, plagiarism detection. We can cross-reference and double check through these various records to determine, hey, is this particular idea something that actually originated in this paper as novel, or something that appears elsewhere? Now, to actually do any of this citation analysis efficiently, it takes a long time for a human to do that. So we might create AI and use natural language processing to automate this detection. But AI is susceptible to garbage in, garbage out. If you feed it bad data, if you train it on bad data, then it will only give bad results. So we need to have a good way to manage our citations such that we don't create garbage in. So before I get too much into the question of what bad data could look like, or how to fix anything like that, I first want to give a little bit of context of some of the types of data that we're looking at. And so welcome to the world of tech. That is spelled T-E-X, but pronounced tech. And it's a typesetting system for writing papers, posters, presentations, books, etc. That's really commonly used within science, technology, engineering, and math, and often chosen instead of Word or Pages or other word processors. Now, authors that use tech will often pair this with a formatting system and reference management system called BibTeX. And that refers to both the file format for how to store that relevant reference data, as well as the parsing engine that will utilize that data when you're actually typesetting a document. Now, notably, BibTeX has a lot of different reimplementations, which I'll briefly touch on in a moment, but perhaps the most famous is BibLaTeX, which instead of being both a parsing engine and a format, BibLaTeX is a format which pairs with a parsing engine called Bibber. And just for reference, this presentation that I'm giving today was written in tech. So the general pipeline that we're working with when you might use tech to prepare a document, if you're not using an automated bibliography formatting system like BibTeX or BibLaTeX, you just write your paper, you'd put in your citations manually, format it manually, and then a tech compiler would read all of that markup in the tech format and return a typeset document. Easy peasy. Of course, it puts more challenge on the person actually putting together that document, but it requires less headache and less computation time. If you want to have an automated formatting, you would put together your paper referencing citations in a BibTeX file or a BiblioTeX file. The tech compiler would then parse that, return a first pass on typesetting with a temporary file for all of the references you want to cite. BibTeX then, or Bibber, would then take that data, parse it, returning those references as formatted based upon the bibliography style that's been requested. The tech compiler would then take that back, parsing again, injecting all of those references where they're supposed to be, and hopefully the process ends there. Unfortunately, it might get thrown back to BibTeX if there's an error that appears, or you'll end up getting it sent to some other tool that you might be utilizing, and then it gets sent back to the tech compiler, and that cycle can repeat. And the more passes that are required, the higher likelihood of breakdown. So specific to the question of BibTeX, where could these breakdowns occur? Well, let's just understand that by way of anatomy. We start any entry within a file by using the @ symbol. And then in blue, we have the entry key, for this case, article. That defines what that reference is. Maybe it's an article, maybe it's a book or an online resource, maybe a patent. We then continue with an open curly brace. Then in green, we have a citation key, an identifying code or set of letters and numbers that allows us to say, this is the record we're talking about, and this is the relevant data we want to access. In Fuchsia, we have our attribute names, author, journal, etc. Names that are relevant to specific attributes of a entry. And then in our yellow, we have the actual value of that attribute. So we know that author corresponds with Orrin Potashnik for this particular entry. In between, we have an equal sign, and then we surround our attribute value in quotations, end that line with a comma, and continue all the way down until we want to end the entry, which we note with a curly brace. So this has all been around for quite a while. This is not a new system. This is quite an old system. Tech originated in 78, built on further in 84 by Lampour. Orrin Potashnik then worked with Lampour to create BibTeX later that year. There's lots of different versions, BibTeX U, BibTeX 8, CL BibTeX, etc. With BiblioTeX being the main format reimplementation. And each one of these reimplementations differ from that origin of BibTeX. Many doing formatting slightly differently, parsing files slightly differently, and breaking differently. But all of these suffer one of the major challenges, which is common to a lot of open source software, because all of this code was developed for the community, by the community in an open source style, barely being charged for it, or sorry, barely charging for it. And the problem with open source code is that while it's much more free, open, and democratized for everyone's use, it also has the challenge of the only folks who will be working on it and fixing it or maintaining it will be those who are dedicated to using it. And there isn't a significant amount of incentive to fixing a problem if there is one, other than you want to fix it for yourself. So some of the challenges that you can run into are inconsistencies across different reimplementations, depending on what acceptable format might be or how to parse a certain set of information. Example would that be that some formats of BibTeX might accept both quotation marks as well as curly braces around an attribute value, while others, and including the original definition of BibTeX, would only accept the quotation mark, as I showed in my anatomy of a BibTeX entry. Some have variable levels of tolerance for BibTeX and LaTeX reserved characters, such as the %sign, the $sign, where if that character appears without a proper care, it will completely break and you won't be able to compile a document. It won't be able to parse in that citation reference file. Commas are a common source of error, especially in the author attribute field. And they double commas, if you improperly space commas, and anything related to the word and will break. And in fact, I ran into that error when I was even preparing this presentation. And you can find at least hundreds more errors of people complaining of how to fix things on Stack Overflow threads, as well as on GitHub. So we wanted to create our own format and create a new system to build from in the general principle of, well, if you want to create a new system to move forward in, you first want to start with a strong foundation, and that strong foundation is in our format. So when we were creating this, we had some general design considerations, which relate to the idea of defensive coding. And that first consideration is to simplify formatting to make it easier and faster for both computers and humans to read a specific entry. The other one is to increase interoperability with other data formats, perhaps outside of the tech community, such as MARC and BibFrame, which are common to librarian and information sciences as it was created by the Library of Congress, as well as JSON and XML, which are common to the world of web. Now, this is defensive coding because you are trying to build something which is simpler, which is more structurally sound to avoid errors that are caused by poorly formatted data, as well as prevent algorithm errors caused by reading bad data. So you have both perspectives of both data and the algorithm. So what we came up with is Project BabbleNewt. And this is a sort of brief overview, and I'll have a table in a moment that really highlights things better. We have 5 formats that we can exchange between, where BabbleNewt is our completely novel format. And we've also included PDP BibTeX and PDP BibLaTeX as a intermediary identical to their counterparts outside of our PDP system, which you'll hear more about in the next presentation. Now, we also added 2 intermediary formats between BibTeX and BibLaTeX, as well as between BibLaTeX and BabbleNewt. So there's progressive conversion from perhaps the old ways in towards what we hope might be the new ways. So we've changed some of the formatting, and perhaps most importantly, introduced an unconstrained attribute style where you have any possible inclusion of attribute name. For example, BibTeX, which is specified historically, you have a requirement for the journal, and the attribute name for that particular attribute name value pair is journal. BibLaTeX, on the other hand, calls it journal title, and some other format outside of this set might refer to it as journal name, or perhaps something else localized to a different language. So for the sake of interoperability, in the novel formats of BibTeX Gen, BibLaTeX Gen, as well as a completely brand new format of BabbleNewt, we have added this unconstrained attribute system. So just to look at what that actual formatting would look like, note that on the left, it's the format code for the sake of saving space. Our first line here is PDP BibTeX, again, identical to the original definition of BibTeX by Tashnik. We've still have that same format as I showed you at the anatomy slide, with a specified attribute list. We then iterate on that to find and create BibTeX Gen, where we've only really changed the curly quotation marks to curly braces around that attribute value, maintaining all other formatting, but changing the attribute names to be unconstrained, so it's a little bit easier to interoperate with other systems. Then again, PDP BibLaTeX is identical to the BibLaTeX definition, which has a slightly different attribute list that is specified by the BibLaTeX format. Moving forward, we have BibLaTeX Gen, which makes minor changes to that formatting, exchanging curly braces for square brackets, to make it more analogous with what we eventually went with for BabbleNewt. And again, introducing that unconstrained attribute list concept. Finally, we have BabbleNewt, which is completely different, completely unique in comparison to these other 4 formats. We've done away with the entry type and entry key being a part of the opener of a specific entry. What this does is it removes a significant variable in recognizing when an entry starts. All you need to look for is that @ sign and open curly brace, as well as the only thing you need to look for to close an entry is curly brace @ sign. It's clearly paired. You don't have to go through the extra steps of parsing for what is the entry type. You don't have to go through the extra steps of parsing for what is the entry key, as all of that information can be contained within the attribute name value pairs. Now, what this does is it makes a more JSON-like format, as JSON and XML both enable for much more variation in what those attribute name value pairs could be, and store all of that relevant information within encapsulating opener closer pairs. Additionally, another important thing to note is that by having curly braces and then square braces, it makes it even more clear that an attribute name value pairs surrounding brackets, delimiters of where the attribute value ends and begins, it makes it distinct from that opener and closer. So this actually has a pretty notable time difference in how long it takes for a computer to parse it. And oh, I'm sorry, there we go. And here's a set of timing tests that we ran at a small file. It's almost negligible, just a few tenths or hundredths of a second different. But it really scales up at 8,000 records, where you actually have 6 seconds difference. Now this, for just everyday compiling typesetting, doesn't make a huge difference, but if you're actually running some sort of citation analysis, you might have to recheck, reconfer with some format data, as you may not be storing all of a large amount of records in memory. And so being able to have a significant increase in speed will make an impact later on. So where to go from here? We have a format. What do we do with it? Well, we want to implement our own bibliography tool analogous to BibTeX or BibTeX 8 or Bibber, but instead built off of the PDP BabbleNewt format. This would allow us to use it in our own typesetting for our own documents. But also we want to integrate PDP BabbleNewt into our NPDS cyber infrastructure and software, again, which we'll hear about in the next presentation. And what this will enable us to do is build out our own FAIR metrics for plagiarism detection with natural language processing by utilizing PDP BabbleNewt in conjunction with NPDS. Again, FAIR metrics is also something I'll hear about in the next presentation. So with that, thank you very much. This is how you can reach me. And here are my citations.
Thank you. Appreciate it, Koby. I just wanted to comment that one of our important goals is the handling not just of 8,000 records, but the handling of 800,000, 8 million, 100 million. There are so many research reports churned out in the scientific literature these days that we really need to be thinking in the millions of records. And that is why developing these kinds of formats and algorithms are frankly not just chasing the holy grail. They really will make a difference when doing so-called big data analyses. And we should also have new specialized processing units. So we'll be moving from graphical processing units. Every new kind of chip is going to have a special name for it. And so we're going to see special chips for big data analysis. So that will give us the opportunity and the power to do meta-analyses and literature analyses on millions of records. So we're getting there, and thank you very much for the presentation.
Of course.
Any questions for Koby? If not, we'll move on.
So
oh, sorry.
Here's a thought. So why not just go straight ahead and use some sort of semantic web format for bibliographic references. Do you think there's, I mean, in some ways it's the most expressive approach you could take, and could, and if you're writing your own software to parse it, you may as well just, there's, you don't really need to conform to, say, older, the conventions of ibtext or some older, or bibliotext or some older format.
Yeah, I think that's an interesting thought. And I think that so part of the challenge is that it allows for a lot more than might be necessary for something as simple as just citing your references, right? It certainly is significantly more expressive and allows for a lot more information to be stored. And so when you're trying to do that large computation, I think that you might run into a bit of a roadblock, at least as of now, to handle that increase in variation. But if we are to keep moving forward, I don't see a reason why not eventually do that. Yeah, I think that's probably about as what I can say for right now.
Yeah, I can add to that just my own observations over the past decades. Um, people have talked about development of the semantic web for many decades, and we still do not have easily affordable, convenient consumer semantic tools that offer semantic editing of XML, RDF, OWL text files, unless or until we get high quality, affordable semantic editors available as tools to the ordinary person. That kind of semantic editing is going to be, frankly, monopolized by the consulting business companies that charge high dollar prices to do that kind of work. So we're a long ways away from the necessary tools and development environments for ordinary scientists who don't have the money from the business world to do that kind of semantic editing. So that's one major counter argument against doing bibliographic citation record formats in a more sophisticated semantic format. So we need to keep things simple. The other major argument against moving to a more complicated or complex semantic data format is the fact that there's just incredible inertia out there. Many of the publishing companies that are for profit are incredibly slow to change. They have investments in the old technology and the old formats. Even much more agile, willing to move more quickly organizations still have incredibly slow-moving inertia that keeps them stuck in the past. So, for example, IEEE. Most of the formats required for typesetting papers at IEEE are still stuck, frankly, in BibTeX, although some of them are now allowing you to use BibLaTeX. But there's the combination of the lack of affordable tools and the existing infrastructure that will make any progress in transition very slow. And it was these two combined reasons for why we adopted this incredible, painstaking, step-by-step approach where, yeah, we can interoperate with the old BibTeX. Yeah, we can interoperate with the old BibLaTeX. We also have our new BabbleNewt, but we can also interoperate with two transitional formats between BibTeX to BibLaTeX and between BibLaTeX to BabbleNewt. We're trying to make the overall transition to future progress as easy as possible, allowing for as much flexibility as possible to accommodate both the old inertia in the old ways, as well as the challenges in making available semantic tools with semantic editors. Okay, with that, let's take a 1-minute break to change speakers, and I will stop the recording.